microliters of phosphate buffered solution. So if you had the 100 microliters that you added to the 900 microliters of phosphate buffer solution, you now have 1,000 microliters in your little cuvette, 100 of which contain phage. So that's a 1 to 10 dilution. I have 100 microliters of phage solution, 1,000 microliters total. 100 is to 1,000 as 1 is to 10. So my first dilution is 10 to the negative 1. I now take 100 microliters of this solution and I dilute it again, another 10-fold. So this had 900 microliters of buffer solution. I added 100 microliters of phage solution. I got a total of 1,000 again, and 100 of which are phage solution. So again, I've done a 1 to 10 dilution. So all I have to do is move my decimal point one more time. So I went from 10 to the negative 1 to 10 to the negative 2. Everybody see that? And same thing, went to 10 to the negative 3 by transferring 100 microliters into this one, and then to the negative 4, negative 5, negative 6, negative 7, negative 8. So all I did was kept moving my decimal point. Alrighty. So that would be, well, we'll just leave it at that. Okay, now, in these tubes, I already have agar, molten agar. I have 9.9 milliliters of molten agar in these. Well, I'm working with microliters, so I want to convert milliliters to microliters. So 9.9 milliliters is how many microliters? Take your 9.9, which is expressed in milliliters, which is 10 to the negative third. I want to convert it to 10 to the negative 6. Negative 6 minus negative 3 is 3 places. I have to go larger to smaller, milliliters to microliters, go larger to smaller, so I'm going to move my decimal point to the right. So, I just take my 9.9 and I move my decimal 3 places to the right. So here's my 9.9, 1, 2, 3. That's 9,900 microliters of agar. Then I added 100 microliters of E. coli to it. So 9,900 plus 100 is 10,000 microliters total. So in here I've got 10,000 microliters. And now I'm going to add 100 microliters of this phage solution to it. So what have I done? Got to go over here. When I do this step, how much more does it dilute the phage solution to go from here to here? Had 100 microliters of 10 to the negative 5 phage solution. I added it to 10,000 microliters of agar with E. coli in it. So that would be 100 to 10,000. If I just cross off the zeros, I got 2 here, I crossed off 2 here, that's 1 to 100. So I diluted it by 1 to 100. Over here, I was diluting by 1 to 10. I moved my decimal 1 place. Over here, I'm moving 2 decimal places. So that's why I go from negative 5 to negative 7, because I moved 2 decimal places. I diluted it by a factor of 10 and another 10. Okay, so that's how we got those calculations. Then I just simply poured this on the top of the base agar, let it solidify. When I come back on Thursday, I'm going to look at my plates, and I'm going to decide, maybe this one has, imagine the whole plate is solid, cloudy, is cloudy. The whole plate's cloudy. And then I'm going to have some clear plaques on it. So maybe this plate only has 2 plaques. It's not really a good number to count. Low numbers are usually not too reliable. Maybe this plate has however many plaques on it. Maybe this plate has many more plaques. They're smaller, but there's a lot more of them. Whatever, drawing circles. Maybe this one has so many plaques, it's too many to count. TMTC, too many to count. I'm going to pick my best plate. Which one has a good number for me to count? You want somewhere probably between 100 and 300 maybe, okay? Let's say I'm too lazy to count the whole stinking plate, but I did a pour plate, so it should be evenly distributed. So I can cut my plate up into 4 pieces, count one of the 4, and then just multiply by 4 to get the total. Or if I can, just count every single one on the plate. I've had students take their plate and take a picture of it and put it in their art program, and then put dots on each colony in their art program. I've had other students just literally use their Sharpie pen and put dots everywhere they see a plaque and count that way by going 1, 2, 3 and literally dot them so they know which ones they've counted already. So it can be done. I also have a colony counter in the back of the room. What it is a light table, so the light comes from behind so you can see better, and it has a grid. So you could count how many are in a grid and then multiply by the number of grids. But anyway, you're going to pick your best plate and count the number of plaques on that plate. Now in theory, where there is a phage in here, and it ends up infecting your bacteria and creating a plaque here, each plaque represents where there was one plaque forming unit, or one phage, right? So now, if I know how many plaques I have, I can multiply back to get a good estimate of how many phages I started with in my initial solution, okay? So what you're going to do when you come on Thursday is pick your best plate and count up the plaques. You could actually count up each plate and do the calculation for each plate. They should be pretty close. Sometimes they're not so close, but it should be pretty close. But let's say you just pick one plate. Let's say you pick that one. Then you're going to have to do this green calculation. I don't know how well you can see it. The formula, it's in the method for spread plate and pour plate. They tell you how to do a serial dilution in that protocol. The formula we're going to use is T equals N times P times D. They have like D times P times N, whatever. It doesn't matter what order, because we'll know. T is your phage titer. Your phage titer is this. We want to answer this question. What is the concentration, or density might be a better word. I think the word density is on your test. What is the density of phages in the original stock solution? That's what I'm doing. I'm trying to answer that question. That's why I went through all this crap. And that would be my titer. I want to know how many phages are in my original solution. And I want it expressed in plaque-forming units, or phages, per milliliter. Okay? So, how am I going to calculate it? First, I'm going to have to write the number of plaques I counted on my plate. So if I pick this plate and I counted, how many did I say? I counted 200 plaques on it. Okay? Then I need to multiply it by the plating factor. What the hell is the plating factor? The plating factor is this. How much did you put on the plate that you counted? So I plated 100 microliters of my virus solution. The plating factor actually is an inverse number, because remember, I got to calculate back to this. So when I was diluting down, I got it down to 100 microliters, but when I go back, it's going to be the opposite. So your plating factor is 1 divided by the amount that you plated of the virus solution. We plated 100 microliters, but we want it in milliliters because my titer has to be expressed in milliliters, right? So 100 microliters is the same as 0.1 milliliters. Remember that? 1 divided by 0.1 is 10 milliliters. So this number is 10 milliliters. So I have